Final project, Coca-Cola measurement by the F team, conformed by Farid Ruiz, Francisco Pacheco, and Francisco Esparza. This project was about getting the exact measurement or volume of a Coke of 6 milliliters. The problem here was to getting the exact number of equations or the exact value of the equation to get the variation of the Coke. So we decided to use Desmos to get a kind of an idea of how we could get the integral of this Coke. Obviously, to get the exact volume of the Coke, we gotta use a kind of a formula. So we decided that using the exact integral, we could use like a volume formula. So we decided to use the sphere formula. So we basically just get to the square the value of the integral of the unit squares. We get it to the square, and then that result we multiply it by pi. Also, it's important to say that the integral that we use was the sine integral, without a little bit of variations to get the exact point to be like a kind of a Coke.
Well, pretty much we needed to discover what was going to be our overall radius from sine at its highest point. This at first was confusing due to being a circular shape and being difficult to measure. That's why we used the volume as an objective and marker. So the formula we thought would be the answer is one where you divide the volume by pi. This will get you around 191 units, but you still need to obtain the radius. So what we did was to divide 191 over 24, 24 being the height of the bottle. We got this from an official source, and we got 7.95 units, which is the radius square. The only thing left to do is to obtain the square root of it, and you'll get the answer. Care to say that this was our comparison method, and in order to obtain the integral we used to graph it on Desmos, which was the tool we used, we actually required to have a bit more of a complex thought about how would the Coca-Cola company would make their bottles. If they were using math, which operation would resemble more the shape of their bottle?
To find the limits, we had to search what is the height of the container. We found that the height of these containers are 24 centimeters, so we decided to put 0 and 24 as the limits. In the videos, we decided to multiply times pi because it's in 360 degrees, and because we had to follow the equation volume is equal to integral pi parentheses f of y squared dy. We decided to use sine because the container has a similar form of the curvature of the sines. We started to find integrals trying to solve for 600. So we put 600 integral limits 24 and 0 pi parentheses f of y close parentheses squared dy. That's the equation. It will be a cylinder, but it isn't. So we put sine in the integral